All right, who can tell me what they believe a composite figure is? Sophie? Say it one more time, I'm sorry. Okay, two shapes put together to make another shape. Can it be more than two shapes, do you think?
Yeah.
Probably.
You take one shape and take it out of the other. Like if you have like a square thing and like prison, you take the shape out in the middle and you take that part out.
Okay, so it could be you're taking a shape out. It's not always something that's stacked. So a really good example, like real life example, is an ice cream cone. Right? So an ice cream cone, the actual cone is what shape? A cone. And what about the ice cream? A hemisphere, right? Well, what if I have 2 scoops of ice cream? Then I have 2 hemispheres. So I have a cone, a hemisphere, and a hemisphere, right? So it doesn't just have to be 2 shapes. It could be more shapes than that. All right, so and you can write however you want, but a figure consisting of 2 or more, 2 or more figures. You can use your definition, but a figure consisting of 2 or more figures. We're going to break this down as we solve so that we can find all the pieces. Because if you do one part of it correctly but another part correctly, technically your final answer is going to be wrong, but you'll at least have your part of your answer correct. Okay? So if I look at number 1, what 2 figures do you see? I see a cylinder, and what else? And a hemisphere. Okay, I see a cylinder and a hemisphere. Can I find the volume of each of those figures individually? Yeah, so let's start with the cylinder. What is the general formula for cylinders? Base area times height. Okay, and we replace that base area formula with what? Pi r squared. Okay, so I need to replace the r. What's the radius of the cylinder? 6? How'd you get 6? Okay, you know the diameter is 12, so half of it's going to be 6. So volume equals pi times 6 squared. And what's the height of the whole cylinder? 13. All right, in your calculator, 6 squared times 13 gives me a grand total of what? 468 pi. I'm going to leave that there for a second, and I'm going to find the volume of a hemisphere. So to find the volume of a hemisphere, remember we start with a sphere and then divide by 2. What's the volume of a sphere? Look at your paper that I just handed you. 4/3 pi r cubed. Is my radius going to be the same as it was in the last problem? Yeah, because you have a diameter of 12, so my radius is 6. So volume equals 4/3 pi, and then 6 cubed. So in your calculator, this is where we're struggling a little bit, I think, on this particular problem. So 6 to the 3rd equals,
16.
oh, yes. And then times, and then make sure you put 4/3 in parentheses, or do times 4 divided by 3, and you should have gotten 288. Make sure you can plug it into your calculator and get 288. So volume equals 288 pi, but what's that for? A sphere. I need a hemisphere. So I'm going to divide 288 by 2. So I really have volume equals 144 pi. Are we okay with that? Okay, so we have our cylinder, we have our hemisphere. But a composite figure means you're either stacking the figures together or theoretically pulling something out. In this case, we're stacking. So what do you think we're going to do with those two answers? Add them together. Because they each have pi, we can leave pi in our answer. If one of them had pi and one of them didn't have pi, we'd have to multiply by pi in order to add them together. Okay, so 468 plus 144 gives you what? 612 pi, and what would my units be? Inches cubed. Okay. If I wanted a rounded answer, I would multiply by pi. And to the nearest tenth, we get 1,922.7 inches cubed. So you'll just have to read what it's asking you for. So with each of the composite figures, find them separately, and then you're going to either add or subtract. Okay? Let's do another one together. What two figures do you see in number 2? Triangular prism, okay. All right, so a triangular prism and a rectangular prism, okay. So let's deal with the triangular prism first. So that's the one that looks like a tent. What's the general formula for a prism? Base area times height. And if we're dealing with a triangle, we're going to replace the B with what? 1/2 base times height. Okay, so let's fill in what we know. Take 10 seconds with your group and determine the base and the height of the triangle. Look at with your group, what is the base and the height of the triangle?
It is 6, 4, 12.
All right, what is the base and the height of the triangle? Base and the height of the triangle? 4 and 6. Okay, so 6 would be here, right? And we know that's 6 because this length is 6. And 4 creates the 90-degree angle. So 1/2, 4 times 6. And what's the height of the entire prism? The triangular prism? 6. So this 6 connects the two triangles together. Okay? Remember, the height of prisms connect the two bases. So since our base is a triangle, it's going to connect those two bases. So 4 times 6, all divided by 2, gives you what? 72. So the volume of the triangular prism is 72. I'm going to leave that there for a second. And I'm going to look at the rectangular prism. So same general formula, but that big B gets replaced with length times width. What is the length, the width, and the height of the rectangular prism? 12, 6, and 4, right? So 4 times 6 times 12. What'd you get? 288. Okay. So again, in this case, we're stacking the two together. So we're going to add the two volumes. 288 plus that 72. 360 feet cubed. Okay. I would like you and your group to do numbers 3 and 4. 3 and 4. So identify the two figures you're solving for, and then find the composite figure volume. All right, what two figures did you see here? A prism and a cone? So a cone and a rectangular prism. Okay, general formula for a cone. 1/3 the base area times the height.
Good. Nope. Ready. No.
9:31 a.m. It's October 1st, 2019.
Okay. 1/3 the base area times the height, and we replace the B with what? What's the shape of the base? A circle. So we're going to replace B with what? Pi r squared. Do you notice I ask the exact same questions every single time we do a problem?
I do. But I pay attention.
Okay. Shh. What is the radius of the cone? 18. What's the height of the cone? 62. So in my calculator, 18 squared times 62 divided by 3 gives me 6,696 pi. Right? I'm going to leave that there for a second. I'm going to work on my prism. Volume of a prism is base area times height. What's the shape of the base? A rectangle, so I'm replacing B with what? Length times width. What is the length and the width of that prism? Okay, so 46 and 46. What's the height of the prism? 5. 46 times 46 times 5 gives me 10,580. Now, what's the difference in this problem compared to number 1? Okay, one has pi, the other doesn't. So I need to multiply this by pi in order to combine those two. So 6,696 pi, and all round, gives me 21,036.1. Yeah? Plus 10,580 for a grand total of, oh dang it. Hold on. I did something on my calculator. $31,616.1 centimeters cubed. Did we get that? Yeah? Okay, number 4. What are my two figures? A cone and a hemisphere.
Which is an ice cream cone.
You're right. So a cone and a hemisphere. General formula for a cone is 1/3 base area times height. And what do I replace base area with? Pi r squared. What is the radius of that cone? 3. So it shows you up here that all the way across is going to be your diameter, which is 6. My radius is then 3. So 1/3 pi times 3 squared And what's the height of the cone? 13. So 3 squared is 9 times 13 divided by 3 gives me 39 pi. Okay. Hemisphere, I'm going to start with a sphere. Volume of a sphere is 4/3 pi r cubed. What's the radius? Still 3. Three to the third is 27 times 4/3 gave you what? 36 pi. Can I combine these as is? Yep. So 39 plus 36 gives me 75 pi centimeters cubed. And if I wanted a rounded answer, I'm going to multiply by pi at the end, giving me 2,300. Nope. I didn't divide by 2. Thank you. Sorry, it should be 18 pi.
I think you put 3 instead of 13.
Okay, hold on. Shh. 3 is right. Where's my... Oh. Let me fix this. Sorry, I did not divide by 2. Thank you. So 39 and 18 gives you 57. Is that better? So 57 pi. Some of you were just going to let me keep going and not even say anything.
Oh, they're bringing it up.
Oh, they were? Just quietly? And then 57 times pi is 179.1. Are we okay with that? Everyone good? Okay. So let's look at number 5. Number 5 is a little different. What's the difference in number 5 compared to the first 4? Okay, so the shape's inside, or technically that middle part is pulled out. Okay, that middle part's being pulled out. So let's start with the 2 figures that you see. Cylinder and a prism. Okay, so let's start with the cylinder. Volume equals base area times height, and my base is a circle, so pi r squared times height. What is the radius of that cylinder? 2, okay. And what's the height of the cylinder? 12. It's going to be the same as the prism because it goes from top to bottom. So 2 squared is 4. 4 times 12 gives you 48 pi. Okay, let's deal with the prism. General formula is base area times height. And the base area gets replaced with what? Length times width. So what is the length and the width of this prism? 10 and 14, and the height is 12. What'd you get?
1,000.
Okay, so first of all, do you notice that one has pi and one doesn't? So let's change this 48 pi and round to the nearest tenth. What is it going to be? 150.8. 150.8. Now, because the cylinder is being taken out of the prism, we're going to subtract. So unless they're stacked on top of each other, you're not going to add. If one's inside the other, it's being taken out and we're going to subtract. So 1680 minus 50.8 gives you a volume. Oh, I said 50.8, but I typed in 150. Thank you. Gives you a volume of 1,529.2 inches cubed. So really what we're looking for in this one is, this is like a box, obviously with a cylinder in it, and we want to know how much water fills up around the cylinder. Okay, so that's why we have to take out that middle part. Okay, same thing here. This is a donut. Okay, so let's figure out how much volume this donut has. Right, you're taking out that middle piece.
No filling.
No, there's no filling in this donut. I want you in your group to do that one. Okay, you saw 2 cylinders. How did you differentiate the cylinders? Did you just write cylinder? Yeah, cylinder and cylinder. It may be helpful for some people so you remember which one you're working on, which one's the big one and which one's the small one. So you'll notice I wrote big cylinder and small cylinder, but you do you. Okay, but something to think about. Formula for cylinder is base area times height. My base is a circle, so pi r squared times the height. If I'm doing the big cylinder, what is the radius of that cylinder? 9. So volume equals pi times 9 squared. And the height? 3. 9 squared is 81. 81 times 3 should have given you 243 pi for the larger cylinder. Yes? Okay. Small cylinder, I'm using the exact same formula, except my radius is now 5. Is my height the same? Yes. So 25 times 3 is 75 pi. I'm going to write it as 2 answers. 243 plus 75 gives me a total of 318 pi meters cubed. Oh, I did add. I'm just like going for it today, aren't I? Okay. Why should I subtract? Taking it out. Try again. 168? Okay. Shh. 168 times pi. 527.8 meters cubed. Okay, so I'm a really good example of not paying attention. I'm just like going for it and doing the motions of what we normally do. Make sure that as you're going through these problems, you're paying attention to what formulas you're using and whether the composite figures are attached or something's being taken out. Okay?